My dear students, today I am going to discuss physics for class 10. In class 10 physics, in the chapter of light, there are very important concepts. So I am going to discuss a few concepts: optical medium, optical density, refraction and refractive index. So first of all, let us see what is optical medium. Now any medium like air, water, glass, oil, diamond, you follow? Now there are some more. Now these are called optical medium because they are transparent and through them light can pass. So any medium, any transparent medium through which light can pass is called optical medium. So these are some common examples of optical medium. Now wood is not optical medium. Wood, paper, so these are not optical medium. They are not optical medium because through wood, through paper, light cannot pass. So optical medium is one through which light can pass. It must be transparent. Okay. Then let us see next important term, that is optical density. Optical density. Now in physics, we have learned the term physical density. Physical density, and you know the formula also, mass by volume, isn't it? Physical density is mass by volume. It has SI units and all that. Now optical density is completely different from this physical density. You follow? Optical density is different. Now optical density has no unit. It has no unit. So in physics there are some more unitless quantities. So this is one of those. It does not have any unit. Alright. Now optical density, how will you define it? So you will define it as the property. So optical density is the property, or you can say capacity. So property or capacity of a transparent medium, of a optical medium, of a transparent optical medium. So optical density is the property or capacity of a transparent optical medium, with the help of which, that means by virtue of this property, the optical medium changes the velocity of light. Changes the velocity of light passing through it. Changes the speed or velocity of light passing through it. Alright. So optical density is a property or capacity of a transparent optical medium, with the help of which the medium changes. Changes means it can increase or decrease. It can increase or decrease. So changes, that means increase or decrease the velocity of light. You followed? So when light passes from one medium to another, suppose there is one medium A and another medium B. So these two are optical medium. Alright. Now suppose light passes from A to B. Okay. Now when light passes from A to B, it enters B, then B will increase or decrease its velocity. So B has a capacity or property to increase the velocity of light as the light enters into it. So this property is called, this capacity is called optical density of that medium. Alright. Now different media has different optical density. Alright. Now in class 10 book there is a list starting from vacuum up to diamond. So these are some optical medium. So in your class 10 book you will find starting from vacuum up to diamond. Alright. So these are some optical medium and they have different optical densities. Okay. Now vacuum has the lowest optical density. It has the least, you can say. Vacuum has the least optical density and diamond has the highest optical density. So vacuum has the least optical density, VACUM, and diamond has the highest optical density. Then in between there is water, there is glass, there is oil, etc. Okay. Now, if now between two, suppose that again let us consider these two optical medium A and B. So A and B are two optical medium. All right. Now suppose optical density of A is greater than optical density of B. If optical density of A, medium A, is greater than optical density of medium B, then A will be called denser medium and B will be called rarefied or rarer medium, RARER. So optical density of A is greater than optical density of B. For example, you can compare, suppose, air and glass. Air and glass. Optical density of air is glass and air. This is glass, this is air. Optical density of glass is greater than optical density of air. So therefore we will call glass denser medium, we will call air rarer medium. Alright. So when you compare two media, so if a medium has greater optical density than the other, then the greater optical density medium is called denser medium and the smaller optical density medium is called rarer medium. Now here A is denser, but then there may be another medium C. Suppose there is a medium C whose optical density is greater than medium A. Then A will be rarer and C will be denser. You followed? In this case, optical density of A is greater than optical density of B. Therefore, A is denser, B is rarer. But in this case, optical density of another medium C is greater than optical density of A. Therefore, C is denser, A is rarer. Now, in this comparison, A is denser, but in this comparison, A is rarer. You followed? Now, optical density, if optical density is greater, then velocity of light in that medium is smaller. Now suppose here this is denser medium, this is rarer medium. That means optical density of A is higher, optical density of B is lower. Now velocity of light in A will be more. Velocity of light in A will be more, or A will be less. And velocity of light in B will be more. So you see, in denser medium, velocity of light is less, and rarer medium, velocity of light is more. Now if you compare these two, this is denser medium, this is rarer medium. So in this medium, velocity of light will be less, and in this medium, velocity of light will be more. So if you compare this medium C and medium A, C is denser, A is rarer. So in which medium, by comparison, in which medium velocity of light will be more? In a rarer medium, and velocity of light will be less in denser medium. Then when you compare A and B, velocity of light will be more in medium B because it is rarer, and velocity of light in medium A will be less because it is denser. So you see, optical density and this velocity of light is inversely related. So optical density of a medium is inversely related to velocity of light in that medium. So if optical density is more, then velocity of light in that medium will be less. All right. Now, in that list which I spoke about a few minutes ago in class 10, you have so vacuum to diamond. You see, now vacuum to diamond. Now vacuum has the least optical density. It has the smallest optical density. Therefore, here the velocity of light will be highest. And diamond has the highest optical density. Have you followed? And therefore, velocity of light in diamond will be least, smallest. So in vacuum has the least, smallest optical density. Therefore, velocity of light in vacuum will be highest. And diamond has the highest optical density. Highest optical density, diamond. Therefore, velocity of light in diamond will be least. So what? So you see, this optical density and velocity of light in that medium inversely related. If optical density is more, velocity of light will be less. Therefore, if you compare air and glass, now optical density of air is less. Therefore, velocity of light in air will be more. Optical density of glass is more than that in air. Therefore, velocity of light in glass will be less. So, air is rarer medium. That means optical density less. Therefore, velocity of light will be greater. Then glass, which is denser medium, optical density high. Therefore, velocity of light will be less. You follow? So, this relation you have to remember, it is like a formula. Alright? Okay, now let us go to the next important concept, that is refraction. Refraction of light. Okay? Now, say when light passes from one medium to another. Now consider, just let me draw here. Now suppose this is medium A, which is rarer. This is a rarer medium, suppose. This is a rarer medium and this is a denser medium. Alright? Suppose rarer medium, you can say air is rarer medium, then denser, suppose water. Alright? So if you compare air and water, air is rarer medium, optical density less, and then water is denser medium, optical density more. Now suppose light, say this is a perpendicular, and suppose this is incident ray, say a ray of light falls on this. Now this is called interface. That is surface of separation between the two media is called interface. Alright. Now suppose a ray of light falls on the interface. Now this is perpendicular. This line is perpendicular. Now this is the original direction. Alright. Now light is entering from one medium into another. Now this second medium which is called refracting medium, the second medium is called refracting medium. Now this is the first medium, and this is the second medium. Alright. The second medium is called refracting medium. Now light is coming from the first medium entering into second medium. This is the original direction. Now since velocity of light in the two media are different, now this medium will increase or decrease the velocity of light. Now because this velocity of light in the second medium will change, then what will happen? The direction of light will change. The direction of motion of light will change. This was the original direction. Now you see the direction of light has changed because it has entered from one medium into another. Now why direction of light has changed? Because velocity has changed. So you see velocity change leads to, so remember this point, velocity change leads to what? Velocity change leads to the change in direction of light. Change in direction of light. So when light enters from this medium to this medium, so velocity changes because this medium has different optical density than this. Alright? So the light will change direction. Okay? That means light is deviated from the original direction. This is the original direction. So light is deviated. You see? Light is bending, light is deviating. Alright? Or light is deflecting. So this deviation, this change of direction is called refraction. So refraction is what? this change of direction of light. You see, this change of direction of light is the refraction. So this ray of light is refracted when it is passing from one medium into another, because velocity has changed, therefore direction of light will change, and this change in direction of light is called refraction. That means deviation of light, bending of light, refraction of light, deflection of light, whatever word you say. So from original direction, light has changed direction. That means light is refracted, light is deviated, light is deflected, light is bent. So this bending of light is called refraction. Okay. So you see, refraction, what is the cause? What is the cause of refraction? So change in velocity. This is the cause. Change in velocity of light. So cause of refraction is what? Change in velocity of light when it enters from one medium into another. So this second medium is changing the second medium, which is called refracting medium, is changing the velocity of light, and also, and as a result, changing the direction of light. From the original, it is bending. Okay. Now this bending, in this case, you see, this bending is happening towards the normal. This is perpendicular. This is the interface, this is perpendicular, this is incident ray, this is refracted ray. Now this refracted ray is moving towards the normal, you see. This was the original direction, it is moving towards the normal. Now refracted ray moves towards the normal, that means the refraction takes place towards the normal, towards the perpendicular, when light passes from rarer to denser. So when light passes from rarer to denser medium, then light is refracted towards the normal. From original direction, it is bending, it is refracted towards the normal. Okay. Now opposite will happen if light passes from denser to rarer. For example, again, let us see this diagram. Let us see this diagram. So suppose this is denser medium. So this medium 1 is now denser, and medium 2 is now rarer. So denser, that means optical density higher, and rarer, that is optical density lower. So we can say, suppose water, yes, let us say water, and suppose rarer, let us say air. Okay, it can be water or glass, this can be air or vacuum. All right. Now say this is the normal, the perpendicular. Now consider this is the incident ray. This is the incident ray. This is the incident ray. Now this is the original direction of the incident ray. So you see, this dotted line represents the original direction of the incident ray. Now light is passing from denser medium to rarer medium. So here this second medium, rarer medium, is the refracting medium. Now in this case, light will be refracted away from normal. So the light will move now this way. So you see, now it is bending away from normal. Okay. Now again, so compare. In this case, rarer to denser. So this light is bending towards normal. This was the original direction. And now in this diagram, you see, light is moving from denser to rarer medium. And so it is moving away from the original direction. That means bending is away from normal. This is the normal. This is a perpendicular to the interface. Okay. So this point you have to remember. That is, the light traveling from rarer to denser, what happens? The refraction happens such that the refracted ray moves towards the normal. And when light passes from denser to rarer medium, then also refraction happens so that the refracted ray moves away from normal. This is the normal, it is moving away this side. But whether it is away from normal or towards the normal, what is happening? Refraction is happening. Is it clear? Okay, now coming to another very important term, refractive index. Okay, let us see now this term, refractive index. Refractive index. So actually this is the most important of all this concept that we discussed today. Refractive index. Refractive index of of a medium. Okay. Now again, speaking about that list in your class 10 NCERT book, there is a list from, as I told you, vacuum to diamond. Now vacuum has the least refractive index and diamond has the highest refractive index. So vacuum has the least refractive index and diamond has the highest refractive index. In between, air, glass, oil, etc. are there. Okay. Now what is refractive index? Now refractive index, this word index means what? Measurement. The word index means measurement. Now refractive index, that means measurement of refracting power of a medium. So measure of the refracting power, refracting capacity of an optical medium. Alright, that is called refractive index. So index means measurement, measure. So refractive index of a medium is what? The measure of refracting power of that medium. Okay. If the medium can bend light more, suppose I mean, say this is air, and suppose this is water, and suppose this is diamond. Okay. Now consider this incident ray. One thing now regarding refraction, just let me tell you one thing regarding refraction. Now light has to fall on the interface of the two medium obliquely. You see, this is important thing. Light must fall obliquely, then only there will be refraction. If light falls perpendicularly, suppose this way. Now if light falls perpendicularly, suppose this is medium 1, this is medium 2, and light incident light is perpendicular to the interface. That means the surface of separation between the two media. So this is 90 degree, this is incident ray. Then there will be no refraction, it will pass straight. This is called transmission. Not reflection or reflection, this is called transmission. That means when light is incident on the interface perpendicularly, then it will pass straight perpendicularly. So there will be no refraction. So it will pass straight, so that is called transmission. Okay. So for refraction, it should fall obliquely. That means there should be an angle of inclination. This is the angle of inclination. Okay. Now suppose this ray is falling air, and here is the second medium. Second medium is water, but here second medium is diamond. All right. Now this is the normal. This is the normal in this diagram, and suppose this is the incident ray here, and this is the normal in this diagram. Okay. So air to diamond, and here air to water. All right. Now this is incident ray, this is incident ray, this is the angle of inclination. So for obliquely, light ray is incident obliquely. Okay. Now this is denser, rarer to denser. Air to water is rarer to denser. Similarly, this is rarer, this is denser. Okay. Now rarer to denser, as we discussed before, what will happen? Light will bend towards the normal. So this is the original direction. Now light will bend towards the normal. So this way. So this is incident ray, this is refracted ray in case of air and water. Now in case of air and diamond, what will happen? Now you see, this is the original direction and this will be the refracted ray. Now see the deviation. This is the original direction, this is the angle of deviation. Now here this is the original direction, this is the angle of deviation. Now see, angle of deviation is smaller. That means light is refracted to little extent from the original direction. From the original direction, light ray, the refracted ray is bending, but very little. But in this case, see, this is the original direction. The refracted ray is bending by much. So this angle of deviation is more than this angle. These two are called angle of deviation. So diamond is refracting light more than water. Alright. Now say angle of inclination in both the incident same. Suppose this is 40 degree, this is 40 degree, isn't it? But here you see angle of deviation here is more and angle of deviation here is less. That means in this diagram the refracted ray is bending from the original direction by a larger angle. That means refraction has taken place to a greater extent. But here the refracted ray is bending from the original direction by a smaller angle. That means refraction has taken place to a little extent. Alright. So we said diamond has the greater capacity of bending light, water has a smaller capacity of bending light. So refractive index of water is less than refractive index of diamond. That means diamond has greater refractive index than water. That means diamond has greater capacity to bend light than water. So that is the meaning of refractive index. So refractive index, again let me say, it is a measure of refracting power of a optical medium. Now in this example what we saw, diamond has the greater power, greater capacity to bend light. So refractive index of diamond is more and refractive index of water is less. I follow? Okay, now you see, now diamond, if you compare this again this vacuum to diamond, now in the previous discussion we saw vacuum has the smallest optical density and diamond has the largest optical density. So you see, optical density of vacuum is least, optical density of diamond is highest. Alright. Again, this refractive index of vacuum is least, refractive index of diamond is highest. So you see, optical density and refractive index, they are directly related. Optical density and refractive index are directly related. So this is a very important relation. Optical density of a medium is directly related to refractive index of the medium. Right? Now previously we had one relation. What was that? Optical density and that was inversely related, isn't it? Optical density and velocity of light was inversely related. So previously we had one relation. Yes, let me say here. So optical density of a medium and velocity of light in that medium, I wrote before, inversely related. And optical density of a medium and refractive index of that medium is directly related. So these two relations. You followed? So from these two relations what we get? Refractive index and velocity of light. Refractive index and velocity of light are inversely related. So refractive index, optical density and refractive index directly related. And optical density is inversely related to vacuum. Therefore, velocity of light. Therefore, refractive index must be inversely related to velocity of light. So these. Now this is a very important relation. This is a very important relation. Refractive index of a medium is inversely related to velocity of light. That means if a medium has refractive index high refractive index, have followed, then it will have low velocity of light. Then velocity of light will be low in that medium. If this medium has high refractive index, that means velocity of light will be low in that medium. Okay. So these two relations, and from these two relations we get this one. So again I say optical density and velocity of light in the medium is inversely related, and optical density and refractive index of medium is directly related, and from these two we get, therefore, refractive index of a medium is inversely related to velocity of light. Okay. Now refractive index has several formula in the book, in your textbook. So about 3 formula, very important formula, and in class 10 you get numerical sum involving refractive index and velocity of light. Therefore you are supposed to know this relation. refractive index and velocity of light inversely related. Okay, so those numerical problems I'll discuss not today, in my next video. Okay, so I hope this discussion today has been useful to you. Okay, then I'll wind up for today. Thank you and good night.